Hi, Cure architecture is having six stages. Here, first stage is random sampling. The random sampling is used to handle the large data sets given in the input. Generally, random sample fits in main memory of the computer. So, the Cure architecture selecting random sample with n number of data points from the given data set. The random sampling involves trade-off between accuracy and efficiency. So after selecting the random sample, we will apply the partitioning into the sample. So here we are going to partition the selected sample space that is a large sample space is divided into p number of partitions. Here each partition will have n minus p number of data points. The first pass here, the in the partitioned sample space, we will apply the clustering approach. Here partially cluster that each partition until final number of clusters that is reduced into n by p into q for some constant value. Here q is always greater than or equal to 1. So here based upon this, here we will select the representative points. So here after selecting the representative points, we will apply the partial partition. So here we have done partial partition based upon the first pass. Then here we will identify the outliers in this stage. So here you see, after partitioning, here the few number of data points are far away from the representative points. So here this is one representative point, this is one representative point. So here these are all very few data points which are far away from the representative data points. So here these are all the data points are considered as outliers. We have to handle that outliers by using the random sampling. So here the random sampling is used to handle the outliers, and also it will eliminate more number of outliers because these data points are far away from the clustered representative data points. So here this is the data points considered as outliers. Here due to that large distance, that outliers are taking more time for merging into already existing clusters. Suppose here if you are taking the data points, so here this is one cluster and this one is cluster 2. Here we selected these data points are these data points are representative points. So here one representative point, right? So here the distance between these representative points, here we have to identify the minimum distance between the representative points between cluster 1 and cluster 2. So here this two data points are very minimum, so we will take this number of data points will be clustered into one, and these two data points are clustered into another cluster. So these data points are now assumed as a outliers. So these outliers can be discarded uh, from this partially clustered partition. And also if there is any cluster is having a small number of, I mean less number of data points, so look at that, this cluster is having very few number of data points. So this kind of cluster is assumed as a outlier, so it is also going to be eliminated, right? So and the clusters which are growing very slowly also should be identified in this phase, and that is also going to be eliminated. So when it will grow slowly, whenever the cluster data points are very far from this, existing cluster, then it will take more time for merging. So this data point, due to this data point, this cluster is taking more time for merging. So this data point can be eliminated by considering as a outlier. And next stage is cluster the partial clusters. So now we have the partial clusters, then we will apply the second pass of the clustering. So here we will use that n by q partially clusters partitions. Here we will use the representative points are stored. So here you look at that, we have partially clustered the data points in this stage, then again we will calculate the new representative points. We will calculate the new representative points. Suppose if there is any more data point and any more clusters are available here, then here also we will take some representative points. Then we will find out the minimum distance between these two clusters. Then again we will apply the clustering approach. So we will merge that merge that two different clusters by using newly calculated representative points. So partitioning is reducing the execution time. Finally, after getting this big cluster, you look at this. So finally we will get the clusters like this. Then after that we have to label it. So this one will be given as a label C1, this one will be given as a label outlier. So here finally we will write the label to each and every clustered data points. Then it will be stored in the disk, right? So that is what we have to do. So what is the criteria for clustering? So we can define k number of clusters by selecting the representative points. So remaining data points can be assigned into that respective clusters. For this fraction of randomly selected representative points for each k number of clusters, we have to assign that remaining data points to this k number of clusters. So this is the way to use Cure clustering approach for clustering the data set by using hierarchical clustering approach. So the advantage of Cure algorithm is the random sampling is reduces the execution time by identifying the outliers from the partition of this sample space. And also the second part of the clustering of this partial cluster is used to make the hierarchical structure of the clustering by applying the newly calculated representative points. So finally we can label it, so which is more robust to the outliers. So it will easily handle that outliers which are far away from the representative data points in the clusters. Thanks for watching.